Well, we're here at Canria with Lars Bendsen of AC883. If you are familiar with AC883, they are an ISP up in Canada that does all kinds of blade repairs, and one of the more interesting things that they do that's unique is pitch alignment. So this is sort of pitch alignment season when the ground freezes over, and they take their equipment out and make sure your blades are pointing in the right direction, which evidently is a thing, that a lot of blades are not pointed in the right direction.
Yeah, Lars has shared that with us. Big problems all over the place when you guys are doing that.
It's for sure a topic that's become more and more evident. There's more and more people out there doing the same or similar way of detecting a pitch misalignment.
Yeah.
So of course there's more awareness around it now than there was when we started doing it with our methods of doing it. So it's for sure come a topic. Also more engineering reports coming out from NREL and from the German Institute as well.
Yeah.
So there's a ton of report coming out of the damages that misalignment causes.
Yeah, it's like running a car down the highway without an alignment on the front end. You're going to just...
It's funny, if you have your right tire and your car is unbalanced, you go in right away to get it changed, which you don't do with your turbine, you just let it run.
Yeah, because turbines are cheap, right?
Yeah, exactly. It barely costs any money.
So we've been talking with Lars, of course, always great conversations, the knowledge that he has, and the AC883 team. And we've stumbled upon a theory that we want to talk about. Yeah. So with the knowledge of pitch alignment and what you guys see out in the field, and of course seeing all kinds of different OEMs and issues that pop up, you've come across one specifically that we've been talking about. Want to share that with us?
Absolutely. I think it's kind of me throwing it out there, and also to get some great feedback. So it's my theory, and what we have seen is the topic on active pitch, which means you're twisting the blades half a degree every time you pass the tower.
Yep. And the reason they do that is?
Let's do it because if you take some of the what do you call it, what do you call it? I lost the word, right?
It's like like wind buffeting causing
wind buffeting causes take the other way, so we don't have that, and you can actually run in higher winds as well.
Okay, yeah. Yeah, because you don't want that way. If you're running in high wind speed and there's a lot of force coming by, when that tower passes, or when that blade passes the tower each time, you get basically a pressure area of wind, and what they're trying to do is...
It's a little bit of a reversed wake.
Yeah,
call it like that.
Yeah.
And you get more pressure on the tower, so that's why you're trying to avoid it. And it means also you can actually expand the design envelope. That's not my theory, that's a fact. By using active pitch, you're extending the same design envelopes, you get more megawatts out of the same turbine.
So it's an efficiency move.
It's supposed to be, yeah.
Okay. Now, you go out and measure hundreds or thousands of blades while they're running, right? The turbines are running. You're actually watching as the blades kind of sweeps in front of the tower, and you're determining pitch alignment from that little snapshot there. So you can see where active pitch alignment happens, right?
Yeah.
At the bottom.
We should be able to see it, but we can't. So we have clients that, we ask them to take the active pitch off, so we have a more true measurement of the blades, of the rotor's state, so to speak. But some of them forgot to do it or cannot do it themselves.
Oh,
so they're running with active pitch because depending on what access they have to their own controller from the OEM, or what service contract they have, they maybe don't even have access to do it.
Yeah.
They have to call the OEM to take the active pitch away.
And that's way too common in the industry. That shouldn't happen.
I think that's a different topic.
Yeah.
Of the balance between owner and OEMs, that's a different topic.
Yeah.
But my point is that we have seen with or without active pitch, there's no difference in the misalignment.
So when that blade comes by and it's supposed to be moving that half degree back and forth, when you guys are doing your pitch alignments with your actual laser instrumentation, you don't actually see it.
We don't see it.
Now, is that a function of the pistons that are driving the blade not functioning properly, which is a thing because you see a lot of oil and a lot of debris around those pitch actuators?
I think it's many things. It could be the pitch actuator is not working properly. That's one of the issues. Yeah. But it's more consistent. So if it was that issue, it will be only on one blade, but it's on all three blades. If that was the real issue.
If the pitch motor was bad, you would see it on one of them would be bad or something like that.
Just be oil everywhere.
Yeah.
Okay.
But we don't. So my theory is, and based on the real experienced technician in the field, is that it doesn't work. So in theory, if you see we have the blade that's 50 meters long, running on rated speed, let's say 7 or 8 meters per second, we have about 40 to 50 ton of pressure onto the blade.
As it sweeps.
As it swipes down at 40, around 40 tons of pressure to the blade. And we have a 2 horsepower motor or 2 kilowatt motor up here, trying to switch it plus minus 5 degrees within an angle of 10 degrees with 15 RPM.
And that blade itself weighs 10 tons?
And the flexibility in the blade, which it's built in because you want to have a flexible blade.
Right.
So how is that going to work? You want a 2 horsepower motor, 50 meters down, turn a flexible blade with 40 tons of pressure on.
Your theory is starting to make sense.
Well, that's my 2 cents. I'm interested to hear if anybody. There'll probably a ton of those listeners are going to disagree with me, and that's okay.
That's what we're here for.
That's my theory, and that's what I've heard and what I have seen, and also talking to pitch guys.
Yeah.
They love it because they're selling a lot of pitch cylinders, repairing a lot of pitch cylinders. Because the thing is here, you're basically only twisting the rubber sealing. You're not actually moving anything. The rubber is flexible itself because it has to be.
Right. Yeah.
So you're just twisting the rubber sealing, and that got worn out, so the blade is not moving.
So what you're saying is when that blade is sweeping down and it gets near the tower at 6 o'clock, that the active pitch management is engaging that motor to turn that blade a half degree and then turn it back. But because of the forces on the blade, it can't actually do that at a 2 horsepower motor. And so it's just basically spinning. The motor or pitch cylinder is just spinning in itself up top.
Yeah, it's because there's a rubber sealing up here.
Yeah.
So it's basically just twisting the rubber sealing and not actually doing it. And I think even if it didn't, let's say there was a fixed connection without a rubber sealing, then would it then be able to do it?
Would it be
Well, 50 meters down with 40
tons? Or would it
tons,
just trip the motor?
or would it just trip the motor?
Yeah. Either way, if this thing is doing this, moving like that, and if you're talking 15 RPM for the rotor, that's 4 times, or what's the math on that?
So that's 45 times.
Yeah, 45 times a minute.
Yeah.
That's a lot of movement within that thing to get hot.
All
hot,
the time.
Hot and hot and
Yeah,
hot.
yeah.
Constant.
So my theory, and based on what we have seen, there's no difference in our system, whether we use it or not.
How would they know that the system worked in the first place?
They would have had to have had tested it with.
They would have had to have laser shot it, right? I mean, how would you know? You can obviously see the motor working. If you're up in the cell, you
The motor's
can
going to
see that twist happen. But how do they know what's happening way down at the tip?
Well, I believe, of course, you can see the control system that is working. It do its job. They can see that because the actuator is moving. They can see that. But it's a physical moving down on the blade.
Can you see it?
We're producing power on the last third of the blade, of it, whatever, from the tip up.
Yeah.
1/3 up. That's where we're producing power. But do they actually move down there? We can't see it.
So if you can't see it, that means that either one or two things is happening. Either it's not moving the blade at all, or you're putting some unique torsion into the blade. The blade's absorbing the rotation you're trying to impose on it, so you're twisting the blade every time it comes around the tower.
But it's interesting, if it was working as it's supposed to do, then we would see a difference because every blade is different. Yeah. All blades are handmade.
Right.
So unless they have exactly the same twist, which is I doubt they would have.
Can't. Right.
Yeah,
but if they had,
you would see different levels of
different levels of
deflection.
twist.
Yeah.
So, but either way, the design of active pitch management is going to have a wear part in the pitch cylinder. It's going to introduce structural fatigue within the blade. Right. So is the juice worth the squeeze even if it was working? Because we're saying that that's not working as a theory.
Yeah, I don't know the theory behind the blades, if it really has that high an impact. That's somebody had read more school books than I have to figure that out. So I don't know that from an engineering perspective because the blades are flexible anyhow.
Right.
They have to be built flexible. And just the fact that they have to be built flexible is that my theory is it doesn't work. You cannot twist that 50-meter blade in that short time, 45 times per minute, and come back.
Yeah. So
that's my 2 cents from my experience.
So if you had an operator sitting with you right now at the table across from us, and they had active pitch management in their turbines, what would you tell them?
Well, depending on the wind scheme, we have to be careful with that. What wind scheme do you have? Let's say in low wind, very low wind, you would have that twist. I don't know why you would use it in low wind.
Why would you need it?
No, I agree. That's
yeah.
that's my point. In high wind, I cannot see the need for it. I can't. But I would love to see if somebody would argue against me and tell me why my theory is wrong.
Right.
And show it to me physically. I want to see that twist coming.
Yeah.
I would love to see it. I hope it works.
Because otherwise it would just be like, hey, I know you have this in your turbines, but shut it off because you're just causing yourself.
Yeah.
You're actually costing yourself more because now you have another O&M part that you have to repair constantly.
Yeah.
Well, because the concept by active pitch, from a blade standpoint, as blades get longer, is you could make lighter blades.
Yep.
You could use that flexibility to your benefit, make the blades lighter, easier to transport, save a whole bunch of money, materials, right? That's the thought process in it. But if it doesn't actually do the task, then you're really at a big risk of having a major problem.
The theory behind it is also take the load off the tower.
Right.
So that's another thing.
Right.
That means you can increase your design criteria from, I'm just saying, 2 megawatt to 2.3 megawatt, as an example, by having 4 enforced active bits. But if it doesn't work, are you then going over your design envelope, or are you just squeezing it to 105%?
So I want to take this discussion over to mass imbalance.
Yeah.
So mass imbalance seems like it's a more peculiar failure mode, or not so much failure mode, a missed opportunity, I'll call it, that especially on a blade swap out, right? Yeah. They have a blade damage problem, they're going to put a new blade on it, and they just slap on a new blade. That doesn't necessarily mean that blade is matched with the other two that already exist. So now they have this really weird rotation aspect where it seems like 2 of the blades are moving faster than the third one.
Yeah, true.
So how do you detect that? And first, describe that. Like, how do you measure to know, like, that one blade is off weight-wise?
Okay. The first part, you got to start with getting the blade cert.
Yeah, first of all, we need to, when we are measuring, first things first, they're getting the same angle so they are aerodynamically aligned.
Okay.
Let's start there.
Okay.
And after that, then we're measuring the mass imbalance. And we're doing on a rotation, because we come to call it shearing. If everything works well, it should be 120 degrees between the blades.
Right.
But we are measuring the plus and minuses. Time, it comes down a long time. How many degrees is that delta from blade A to blade C to blade B? Right. How much is there in between? And if one is always coming down, a heavy blade coming down faster that way, then it goes up slower to the next one. So we're measuring the delta between in the rotational speed, because it should go like 100% synchron, right? But it doesn't. There's always this, if you have the mass imbalance.
So that is torture on a gearbox and a drivetrain, right?
Absolutely.
Main bearings?
So there are 2 things. One thing is the aerodynamic unbalance. If it's within reason, whatever that means, within a degree, of course they have an impact on the drivetrain. But if you have extreme aerodynamic imbalance, 4 or 5 degrees, which we have seen, then that's equally bad as mass imbalance. So back to the mass imbalance, let's say now we have aerodynamically balanced. Now we have the mass imbalance. And as you said, change the blade. We had some that should be weighted out. There should be a balance. Everything should be good. The clients do not tell us if they have a blade repair. They tell us after the fact, oh, why is this one out? Well, oh, by the way, we actually changed the blade. So on one of them we found there was 82 kilos missing in chamber number 2. 82 kilos missing. The turbine could not run over 7 meters per second. It was stalling.
Sure.
And the blade tip on, you see the what do you call it, when you see the rotation from the side, the blade tip delta was 5 feet. It was 1 meter and 1 meter 20.
So like basically as the
4
blades,
feet.
the blades passed the tower, one of them was closer to the tower by 5 feet.
It was actually, no, it was closer to away from the tower.
Okay, so
because if you see there's 82 kilos missing, it's not heavy enough to not hit the load. It's actually, it's further away from the tower.
Right.
And that was 1 meter and 20, so that's 4 feet.
You could see that with your blind eye.
We can see it and we can hear it.
Yeah.
We can hear the whistling.
Yeah, that's crazy.
100%.
So what percentage of blades have mass imbalances out there?
From what we have seen, we have done about 1,000, 1,200 blades, might be more, not blades, but turbines. Might be done more, I can't remember. But so turbines from 0 to 4 years old, and say 4 to 8, and over 8, let's try to do that.
Yeah.
The newer turbines is about 15-20% are out of bounds. And once you move up, then you're about 30 to 35%. And once you get over 8 years old, it's 35 to 50% out.
Whoa.
And that's I could go more detailed, but that's rough numbers. For sure, sorry, but GE turbines older than 8 years, they're 50% out. Gamesa turbines, 8 years old, we had a site of more than 100 turbines. 52 were out of bounds.
Wow.
So that's some examples.
Yeah.
Okay, that's a lot.
That's
way more than I was thinking it was. So, and that's mass imbalance or pitch imbalance?
That's
Or
aerodynamic. That's aerodynamic.
Aerodynamic imbalance.
Yeah.
Okay. And mass imbalance, where do you think the number is?
I can't. It's hard to quantify. I can't do that because we only see it if we are being called out,
Right.
or we are catching it by coincidence.
So one of the things that I always wondered about is like a insurance case, blade gets swapped out. A lot of times they say, hey, we got to put 3 new blades up because we can't find one. Or if they have a safe harbor blade sitting at the O&M building, hey, that one actually, the weight cert's close enough, da-da-da. Would you recommend that, hey, if you're going to swap a blade out, no matter if it's one blade or you're doing a whole rotor set, if it's a case like that, come out and get the pitch alignment checked?
Should for sure get it done anyhow when you're changing one blade.
Yeah.
Because the zero marker doesn't really give you much. It's not very accurate.
Yeah.
So we have to get a message somehow or get it adjusted. It could be our laser or somebody else, but you need to get it mapped out. Another thing that's important is that the spec sheet from the one turbine we had that was really severe, that was a spec sheet from LM. Tells you where the weight is. And it turns out that person who made that balance did not follow that spec sheet.
Oh.
She was just missing 82 kilos.
Wow.
So that's another thing as well. ISPs, independent contractors, seems like not always being educated to the work they do.
Sure.
Yeah. Yeah, that's an industry-wide problem.
That's industry-wide, but also many turbines are, of course, mostly placed in rural areas. So how do you get qualified?
Yeah, that's tough. That boils down to the technician issue that we're always talking about.
Yeah.
Right.
Training is just one thing.
Back me up on the GE aerodynamic alignment issue. Is that just a wear and tear on the structure, that the twisting of the blade, having done so many cycles that they don't behave the same as they age? Because that would make sense to me. You see that on
Structural fatigue. Yeah,
it's a structural fatigue issue.
Right? I think also that's so the GE, of course, is electrical bits. It could be an encoder that doesn't work properly, or might be the controller get the signal, it does move, but actually it doesn't.
Right.
So that's one thing, and then of course I'm just saying the Vestas, the Siemens, that's hydraulic bits.
Right.
And there you see that's leaking pit cylinders. They're wandering because it's slowly leaking, so you don't get the movement they think they get.
Yeah. But it's easier to see that if you're up in the nacelle or looking in the hub.
You can
it's easier
see
to see a problem with a hydraulic.
Electrical bits, you can't really see it.
Yeah.
So if that's so prevalent, what kind of AEP loss is that? That turns into power production issues.
Yeah, there is power production. You're losing power in the low wind area.
Right.
Not as much in the high wind area.
Right.
The trade-off in high wind, you get way more vibration.
Yeah.
But you have less vibration in low wind, but you're losing power. In high wind, you get way more vibration and you're losing your gearbox.
Yeah. You're wearing components out prematurely.
You're going to pay either way. You're going to pay in low wind in one way and missing production.
Yeah.
So what are the first signs that you know you may have a pitch alignment issue? Is the SCADA system tripping off under high wind conditions? Right. Are you getting alarms that say something is wrong? Vibration alarms?
Vibration alarms, you get that from, say, hey, we have a lot of vibration. This turbine is stalling after 7 meters per second.
Right.
Let's check that. And then we've gone out and then we're digging into it. And mostly we find out it is a aerodynamic imbalance or a mass imbalance.
So I know one of the issues from GE more recently over in Europe, right, was they had a couple of blades snap off, and then they traced it back to a single sensor in the turbine not catching it soon enough. Like there's an issue with the sensors.
Yeah,
That's the story we're being told today.
Yeah, I've seen that story a couple times now, so it's easy to be a pretty consistent story. So if that's the case, is that basically a load imbalance, an aerodynamic imbalance, then that it's not catching the induced vibration?
Of course, if you don't catch the vibration, regardless where it's coming from,
Right.
already there you have an issue, because then again you're going to pay later.
Right.
Yeah.
If that could have been caught by the sensor working, and thereby you could adjust your blade, I don't know, but that's an option.
Right. It's what's the issue though? Is it a mass imbalance? Is it an aerodynamic imbalance? It's not stripping the sensor. Forget about the sensor for a minute. The sensor is there to capture gross errors, right? So if they had a gross error with in a blade, which would cause the blade to fatigue and to break, I would assume that that's a vibration sensor of some sort, and that the issue would be pitch alignment. Could be as simple as pitch alignment.
Could be, yeah. But we see vibration level, we see that caused by both.
Okay.
The shorter vibration level could be caused by aerodynamic imbalance, but that's more a vibration level.
Okay.
If you have a mass imbalance between the oscillation of the tower, and then you're down to the foundation, and then you're really in trouble.
Yeah, because I think that has a lot to do with repowering. So we talked to Onyx Insight for instrumenting towers for the amount of sway they have. There's a couple of companies doing this, but basically they're monitoring the towers from how much sway they have, because it helps them to determine the structural integrity of the foundation when they go to repower. So there's put a slightly bigger blades, maybe a slightly bigger generator on this thing. They have to know what the foundation is doing, and it takes them 12 months to do it. But my guess is that when they monitor some of those turbines, they must be seeing some decent amount of sway.
I mean, we can see sway up to 600-700 millimeters, half a meter and more, easily.
Whoa.
But one thing is the sway, but what if we have the oscillation?
Right, it's not back and forth. It's
actually
it's left and right.
elliptical.
Yeah, it's elliptical,
like
right?
Yeah.
That's a big problem for a foundation.
That's why we have seen, tower collapse. We have seen change of foundations. It's out there. We went to sites where basically there's no dirt around the foundation because it's all shaken apart.
Wow.
It's horrible. Sometimes it's scary, but you see a lot of stuff. But I do believe we were one of the first movers doing this, but there's a ton of people doing it with different technologies.
Right.
SCADA data, which can be done to, might be more data heavy and more on the back end of the engineering department heavy. There's high-speed cameras, different ways of doing it. But it's the same issue we're trying to address.
Yeah.
So we are more people out there doing it, it got more awareness, I believe. That people know, might be it's not only AC883 finding stuff, but there's actually a lot of findings out there.
Speaking of finding stuff, Lars, I got a question for you, because this is something that I was actually talking to someone last night about, is blade bolts.
Yeah.
So blade bolts, whether it's pre-tension, post-tension, however they're tightened, torqued, over-torqued, under-torqued, issues with the torquing guns when they go on, all these different kind of things. If there was an issue in either the blade bolts torquing, breaking, or say like the actual pockets that they're epoxied into starting to move, would you guys be able to find that with your pitch measurement as well?
I think it would be hard for us to tell that is the root cause.
Right.
But there's a lot of boxes we check once we can see it's imbalance. Great, check, that's good. If we still have vibrations, but we have no tower movement, okay, then we might look at the drivetrain.
Yeah.
There could be some gearbox or main bearing issues. If that also okay, but we still have a lot of sway, well, let's check the imbalance, the mass imbalance, which we're also checking, right? So we get the report fully from right away.
So you're using your pitch alignment methodology as a diagnostic tool for the whole turbine.
It's more than just a measurement tool. We also get a lot of checking boxes. Is it that? Is it that? Is it that? It could be different reasons. Blade twists. We have detected huge failures in blades. We had a tip that was twisting 5-6 degrees compared to the rest, and there was a crack in the blade that we found.
Probably a
but that was by pure coincidence.
Right.
That was not why we were on site. But we see a lot of stuff, a lot of boxes you can check once we do that analytics, and it takes 7-8 minutes. That's it, and we get a whole report. Then we are checking some KPIs if they are okay, and then we move on to the next, or we analytics a little bit on site what it is.
Right.
So we're in the peak pitch alignment season because the ground is frozen. That makes life a lot easier.
And we have more constant wind than in the summer, so we need a constant wind speed.
What are your constraints for actually doing the pitch alignment?
Roughly between 4 to 10 meters per second. But it's more important, we need the number of rotations. We need roughly 6.5, 7 RPMs. That means a GE 1.5 with 37 meters blades, they're spinning way faster than a 53 meter blade.
Right.
But roughly 7 RPM would be good for us.
So then this is the time to be calling AC883, right? We're at the end of October. The ground's starting to freeze up in Calgary, clearly.
Absolutely.
It's moving south rapidly because you want to get ready for the season, right? The peak production season. And you want to have your blades aligned and to get rid of some of these historical problems that are happening.
Or if you want to talk to Lars about his active pitch management.
Yeah, you're going to have to talk to Lars.
Absolutely. I'm happy to take the discussion. And I'm happy to be turned around. I would love that.
So how do we find you on the interwebs?
Interwebs is just AC883.com.
Okay, AC883.com.
Yeah, should be right there.
Okay, and then also you can check out on LinkedIn, or you can, especially if you have alignment issues, you can reach Lars directly on LinkedIn and talk about active pitch alignment.
I'm happy to take
a good discussion.
happy to take the discussion. I'm happy to cave in. Totally happy to do that. But that's just my practical 2 cents, and there's probably a bunch of engineers that can tell me different. I would love that.
Perfect.
Yeah, well, Lars has been fantastic. We don't get to see you so much, just at conferences because that's how this works. But and this has been great, and this has been a great conference in Canada. And we appreciate all the support you've given to WeatherGuard. And it's been fantastic. Really, it has been.
Thank you. My pleasure.
We appreciate all the effort there. So you have to take us out for a steak tonight, or Joel and I did steak tonight.
Absolutely.